Hi everyone. Let us start with SetLanguage Exercise 1.2 and question number 3 today. Which of the following sets are equivalent, unequal or equal sets? So in order to find this, before to that, we'll see what are these equivalent, equal and unequal sets in a quick recap. Equivalent sets. Equivalent sets contain the same number of elements. So it can be written with a tilde symbol A and B. Before to that, inside that we have to put this. Now n of A is equal to n of B is the only condition equivalent sets has to satisfy. Now let us move on to equal sets. Equal sets means two sets should exactly contain the same elements, which means n of A should be equal to n of B and the element A in A should be the same as the element in B. So now all equal sets are equivalent sets. Now let us move on to unequal sets. Unequal sets, as the name suggests, they does not contain the same number of elements or same elements. So n of A is also surely not equal to n of B. With this quick recap, let's move on to our question. So here we have to find out whether these are equivalent or unequal or equal sets. First question. Set of vowels in English alphabets. So let us write our set A, which is defined as A, E, I, O and U. So then we have to write the n of A, which means the number of elements in the set A, which is 1, 2, 3, 4, 5. Now let us move on to set B. Set of letters in the word vowel. So let's write each and every letter W, V, O, W, E and then L. So now let us count the number of elements here also. N of B, which is a cardinal number or the number of elements in the set, equal to 1, 2, 3, 4, 5. So this is equal to 5. Now n of A is equal to n of B. So this is an equivalent set. Let us check whether it is also equal. It has A but it doesn't have A. So the first condition, first element is not satisfying so this is not an equal set. So this is purely an equivalent set, which means only the number of elements is same. Equivalent sets. Now let us move on to question number 2. In question number 2, if you could see, C is given directly. So we can write n of C as n of C is equal to number of elements is 1, 2, 3, 4. But D is not direct. So let's figure out D. So D is equal to set of all x such that x belongs to W. What is W? Whole numbers. Whole numbers start with 0, 1, 2 and it goes on like that. But there is another condition that x should be greater than 1 and less than 5. So we can't take 0 and also we can't take 1. We don't have the greater than or equal to symbol. So we have to start with 2, 3 and 4. Can we include 5? No, we can't because the greater than symbol is not there, less than equal to symbol is also not there. So let's stop here. And now if you could see, it is 2, 3, 4 and n of D is equal to again 3. So now n of C is not equal to n of D. So it can't be equal, it can't be equivalent. So finally we'll end up with unequal sets. Okay. Now let us move on to question number 3 in this. Question number 3 is set of letters in the word Y, life. So X is equal to, let us list out the letters L, I, F and E. So this will be n of X is equal to 3. So now if you see the Y is already given. So let's take n of Y. N of Y is equal to, n of X is equal to 4 and n of Y is equal to 4. And also L is here and we have L here also. I is here and then we have I here also. F is here, A is here and also the same. So this is again we find out two conditions, n of x equal to n of y. So they are equivalent sets, and now since we have same elements, they are again equal sets too. So this set is an equal set because it contains same number of elements and the same elements will equal sets. In this question, it is given as g such that x is a prime number and it also lies between 3 and 23. So let us start listing the set of prime numbers which is between 3 and 23. So we can't include 3 because we don't have this greater than or equal to symbol. So let's write the next prime number which is 5, 7, 9, 11, 13, 17. So we can't write 21 and we can't write 23 also because 21 is not a prime number and 23 even though it's prime, we don't have this equal to symbol here and so we can't write it. So now n of g means the number of elements in g is equal to 1, 2, 3, 4, 5, 6. So n of g is equal to 6. Let's move on to h. The set h is defined as x is a divisor of 18. Divisor means a number which exactly divides 18. So let's start with 1. So 1 means when you divide 18 by 1, obviously you will get the remainder 0. Every 1 is a divisor of every number. Now let's move on to 2. 2 is 2 times of 9 is 18. So that is also here, and 9 is also a divisor of 18. And now let us take 3. If we divide with 3, 6 3s are 18. So we can put both. So 6 3s are 18 and we can put 6 also. 4 4s are 16, 4 3s are 12, 4 5s are 15. So it is not there. So we can't include 4. And now if you check 1 18 is 18. So these are the numbers which are the divisors of 18. So now let us give the number, I mean the cardinal number or the number of elements of set h. So let's start counting here. 1, 2, 3, 4, 5, 6. Yes, so now if you see n of g is equal to n of h, which means it is an equivalent set. Let's go ahead and check whether it is equal also. No, it is not equivalent because we have 5 7s here. We don't have such numbers here. So since we have only the equal number of elements and not the same elements, what is the set? Equal or equivalent? Yes, it is equivalent set. So with this, we are ending this session and I will give a neat handwritten of this question in the next slide. You can refer to it. Hope you understood this question very well.